Good morning. Everybody awake? No, not yet. Sorry, by the way, I apologize again one more time for being late. I didn't anticipate the traffic this morning, and I thought I could make it, and I had plenty of time, but of course I didn't. I do live in this area, so it's not that far for me. It's about, on a normal day, it's only about 30 minutes drive, but today it took me longer than an hour. All right, let's talk about some of the implementation challenges in terms of what we've seen so far. This is purely based on my experiences or our experiences as Red Hat and working with many different customers across the board. And then let's tie that back into the panel that was just discussed in terms of how can you work together as a community and collaborate better to make things happen. Now, of course, we have these different charts. I'm sure you'll get all the charts with you. Don't worry about it. The only reason for my putting up this slide is I wanted to separate a few things in terms of terminology with respect to what I use in the presentation. I want to make sure that Open RAN is different from Cloud RAN or vRAN. You can take any vendor's RAN components and cloudify them or virtualize them and run them as part of a platform and run that as part of that particular architecture. That is not necessarily open. Open really means it's different sets of components with standardized interfaces between, as we just spoke about a moment ago, that you have the ability to mix and match components at some point in time. Now, why you can't do that, why you can do that, all of that is part of my discussion and part of my presentation. So that's why I wanted to just make sure I clarify that terminology before and not to be confused with people who use the term Cloud RAN or people who use the term vRAN, and sometimes they always refer to it in the same breath as Open RAN. Of course, we all know the models of these Open RAN components, and we don't need to belabor this point in terms of this particular audience at least, but this is just for different types of deployment models, different types of components in terms of where things can be deployed. But what's critical here is the different interfaces that come into play in the context of Open RAN. The front haul interface, the mid haul interface, the interface to northbound to the to the SMO, the interface between various different components. All of those are critical in terms of having very specific definitions. And ORAN, this picture is from the ORAN architecture in terms of the various different interfaces, what's defined in 3GPP versus what's defined in ORAN. And now what we are talking about in terms of mixing and matching those components and how you use those cloud components as part of this. Of course, my interest, what I represent is Red Hat. My interest is mostly in the OCloud space. My interest is enabling different components on top of the OCloud. And my interest is in ensuring that what David just mentioned a moment ago is possible, which is when you request a resource to be deployed on any given site, on any given location, that you actually achieve the outcome that you want to be able to do that. To make that happen, my experiences is drawn from how people deploy cloud platforms today, how people deploy cloud platforms for different kinds of workloads, for network functions, for IT workloads, and what is the amount of optimization and tuning do they do, and what are some of the known tools that we can leverage in terms of scaling our work here in the Open RAN space. So what are some of the challenges of Open RAN deployments? First question we have to ask today is how open is Open RAN today? This is why I was saying a lot of the people confuse Cloud RAN, vRAN as Open RAN, and it's not necessarily open. Can we mix and match different Open RAN components with each other? The answer is no. Can we disaggregate the hardware from software and then create a level of optionality so that you're actually not prepackaging things? The answer is yes, we can do that. But what about different RUs and and the different RAN vendors with CU, DU from a single RAN vendor and the RU? Well, the answer is it depends. It depends on what interoperability testing they've done. It depends on what work has been done, and then even then there are scare tactics that employ to say, oh well, you can't do that. All right? Can we deploy any hardware and any accelerator? Well, also it depends in terms of what's being tested. And this yesterday, I think there was an interesting panel about, testing. How can we actually improve testing and how can we actually do better? But it absolutely depends on those reference architectures. I think Ganesh talked about a reference blueprint as well. That's important. Then the next question is, what about performance? Are we getting with ORAN the same level of performance that you get today with dedicated hardware? Of course, the big vendors have spent enormous amount of money and time to improve their deployment models, to optimize them. They need to be given credit for that, the 32 by 32 MIMO, 64 by 64 MIMO. And these are, by the way, real. These are not, theoretical challenges. I was in India 2 weeks ago that Seshi was referring to in terms of IMC. I was talking to an operator, and they're struggling with respect to deploying 32 by 32 MIMO in an Open RAN environment. It's hard to get that to work. Now, with a vendor, they already have it deployed with one of the vendors on their closed architecture. So it's not easy. Some of these problems are not easy to solve. What is the footprint that's required when you go to this kind of MIMO capability in terms of servers, in terms of accelerators, in terms of power consumption? And I was actually talking to Telstra. Anybody from Telstra here? No? Okay. I was actually talking to the architect at Telstra, and then she said, let's do some math and let's do some analysis in terms of what I want to deploy in dense urban environments, and what's the footprint that you will get if you deploy a Cloud RAN or a vRAN when compared to my dedicated hardware that's there today. And the answer was a no-brainer. Actually, the dedicated hardware is still, smaller footprint, lower power consumption when compared to a Cloud RAN or a vRAN footprint. So these are some real challenges that I think we do need to worry about, we do need to think about. And then, of course, what about the silicon that's available today, and what's about the accelerators that are different? Different accelerators show up now from Intel, from NVIDIA, from Xilinx, from Qualcomm, right? And all of these have different performance characteristics. Some of them are able to do forward error correction with certain number of channels, certain number of bearers, certain number of DU implementations, and others not. Some are inline, and others are what we call as PSAs. I don't know if you heard the term PSA before, power sucking aliens, right? So they are, and now I think the architectures are improving. And they are getting better. 2 years ago or 3 years ago, the conversation was different. Now the conversation is different with Intel's SPREE and the AMD's latest body of work. You can get some inline acceleration work with some of these cards, and it is improving. But are we there yet? As my son or my daughter always says in the car, are we there yet? And I don't know. I think if we are there yet. So what about the overall TCO, right? We need to look at all of these things. Now, for my practical purpose, obviously, I'm going to focus more on the cloud space and talk a little bit about it. Now, the first thing, if you saw this previous picture, there was this red thing at the bottom there. One of the biggest things that you can do to improve overall cost and optimization efficiency is to actually extend your cloud platform from the core out to the edge and then to the far edge. We've seen that done by a few operators across the globe, where they have actually originally deployed a Kubernetes platform for the core, and they've started to now extend that particular Kubernetes platform out to the edge to do CU aggregation, and now further outside to actually go deploy the DUs. Now, when you move from a core deployment of 5 sites or 10 sites or 20 sites to a edge deployment of CU aggregation points, now you're talking 50, 60, 100, maybe 200 sites. And then when you go out to the RAN DU, you're talking now thousands and tens of thousands of sites. So obviously, automation becomes a very critical element of this. Scale becomes a very critical element of this. Standard definitions in terms of how you define all of those different models for deployment become very critical in that context. And the cloud platform needs to be able to handle what you do in the core versus what you do at the edge versus what you do at the far edge. So what are some of those attributes and characteristics and requirements the cloud platform needs to be able to manage? Well, deploying core is very different from deploying RAN. Deploying RAN CU is very different from deploying RAN DU. You need timing, you need synchronization, you need performance, you need placement, you need optimization, you need acceleration. So all of those, and massive scale and distribution. So all of those components need to be taken care of. And then you need optimized footprint. You cannot deploy a large cluster and then say, okay, I'm going to go deploy DUs there. DUs sometimes are deployed in individual nodes, right, closer to the cell towers, where the front haul access is available for you. Yeah, I mean, in some cases, in dense urban environments, yes, you do DU pooling, and you can have probably a lot of fiber, but that's not always the case. So you need to manage latencies in those type of environments. You need to ensure that you have real-time operating system on that particular environment. You need to define all of those different profiles for that particular deployment on the cloud. And what are those profiles? How standardized can they be? And then as you aggregate up towards the edge, for example, you probably need multi-tenancy capability as well. Kubernetes natively does not provide multi-tenancy capability. So what type of an operational model do you need for OCloud to actually create that particular multi-tenancy? How hard is this hard tenancy environment do you need? Do you need to separate the network functions into each different clusters? Then it goes to the example that David was giving us. Now we have one set of people working with one vendor. They exactly know how to operate that cluster. And you have another set of people who are working with a different vendor who know exactly how to operate that cluster with all of the KPIs, right? So what is important then is abstractions become key. Abstractions of hardware, abstractions of deployment profiles, abstractions of the operating model become extremely key. And then you start to measure yourselves in terms of observability and the outcomes, whether the intent that you had in terms of how you deployed it if that makes sense or not. And now, of course, accelerated data performance is important. We moved from data acceleration core in the data center out towards the edge and the far edge. And we've been working with various different accelerator vendors. I should have had Qualcomm here, but sorry. I don't have Qualcomm here and AMD here, but we do work with both of them as well in terms of this. But what acceleration has also done is provided you some interesting deployment models for the edge and the far edge. Particularly if you actually look at DPUs, if you look at DPUs, IPUs, they are servers within servers, or core functions within core functions. Now you can aggregate in a much different way. You can actually pass off components so that you can actually accelerate those on the line cards, on the NICs in a much better way. And that provides you overall higher performance that allows us to address some of those requirements around massive MIMO and some of those requirements around high performance acceleration, high performance UPF, and so on and so forth. So we do work in terms of, we do work with all of these different vendors to enhance the platform, to actually create that distribution at scale, to provide a level of network security in this particular cloud deployment model, and to address all of the different requirements in the context of RAN, in particular PTP and node discovery and things like build with our partners like Intel, NVIDIA, and Qualcomm and others, Kubernetes operators to go deploy that. Now, one example I can give you is here in this particular chart of how you can actually layer those components or abstract those components at various different levels. So let's say you recognize in a machine config pool, you have a set of hardware that needs to be exposed to the orchestrator, that this is the area where things are in this particular machine config pool. This has a set of accelerators that you desire. Now you have a request to go deploy a workload, then you can actually, either enable that dynamically or actually make that node available for actual placement of that workload. So what we do internally in Red Hat, for example, is you have different, what we call as Kubernetes operators, things like performance add-on operator or SRIOV operator or logging operator. Now these operators provide configuration, monitoring and management of the infrastructure itself to be able to actually enable this capability. So you don't have to go tinker with every little hardware tweak or every little hardware knob that exists or every little performance tuning that you need to do on a given server. So I can define, for example, a RANDU profile. And once I define a RANDU profile, I do, through zero-touch provisioning, I enable my node for base operating system and the cloud platform. And then as soon as I make this node part of either a config pool, then it automatically goes and deploys the RANDU profile and says, okay, this machine config pool is for DUs. I can go down immediately deploy a RANDU profile, which actually tunes the NUMA, which actually enables, the real-time operating system, which actually does A, B, C, and D to make sure that now that node is ready for the deployment of a DU workload. So this is the type of work that we've been doing as part of the OCloud to actually create that optimization, and that's exactly what we intend to bring as part of the ORAN SC as well. And so hopefully we can actually share some of these experiences with the broader community. Now, that brings me to, okay, we need to build a better ecosystem. Disaggregation certainly provides value at each level of the stack. When you disaggregate from hardware, now you can actually use COTS hardware to be able to go deploy that. But then we get into other problems in terms of how do we integrate different levels. But it also means we have to align different RAN vendors, OEM vendors, orchestration tools, and cloud platform together to build a solution. So we need actually an integration component. Now, we are seeing some smaller subsets of ecosystems emerge and mushroom. For example, we've seen Fujitsu, NEC, Mavenir, Samsung, and some of the smaller players actually come up and say, oh, we need to operate with different radio vendors. We have a RAN implementation. We also have a radio, but maybe we need to operate with different radio vendors. So this is beginning to happen, which is actually a very good encouraging sign. And I would totally give the credit to, in terms of ORAN Alliance, to be able to drive this kind of conversation in the industry. Now, is it there yet in terms of broad commercial deployment? No, it's not there yet in terms of broad commercial deployment across any of all of the vendors, but it's certainly happening now at some very large carriers across the globe. Broad interoperability does remain a challenge, and I think we heard from the panel, we heard from a number of people yesterday and today in terms of broad interoperability across all of those different components still remains a challenge. So in terms of community participation, right, it's not just plug fests. We really need to do some core work. We need to do some dedicated work across together to be able to make these implementations robust. And it goes back to my comment that I made on the panel in terms of making sure that we have reference implementations that we learn from and we actually share that across so we can actually encourage that entire community to make that happen. So we really need those robust implementations. Now, community collaborations, I think we've actually talked about this a lot. There are different communities that actually work together. Nefio, ORAN, TIP as part of those plug fests for the ORAN. And then of course, OAI. We've been working with OAI for a long time, and actually it's really heartening to see that all of these communities are now coming together. Now, Open RAN Policy Coalition also drove some at a policy level in terms of providing encouragement, funding. One of the Coliseum projects that you see here is also part of some of that funding that's coming together to actually create this type of environments and make that happen more and more. And vendors also have these private ecosystems, just like ours. We have this ecosystem with different RAN vendors, with different hardware vendors, with different integrators to come together and build these type of reference implementations and reference architectures. Now, believe it or not, I'm going to share my challenge with you that we have to work with an Ericsson to build a reference architecture with them on Dell or HPE or on something. Then we have to work with Nokia to build another reference architecture with them on Dell, on HPE, on different types of hardware. And then we have to work with a Mavenir with a different reference architecture. Now, Mavenir uses, for example, ACC 200 or ACC 100 with Intel. And now a different operator wants Qualcomm, card for the accelerator, or they want an NVIDIA for the accelerator. And now we got to retune that particular reference architecture. It is hard. It is a lot of work that we have spent and done for a long, long time. If there was a better way of enabling these abstractions, defining these hardware APIs better, and actually doing a better job, my life would be a lot easier that I could simply say, just go use it, right? But unfortunately, that's not the case. So what is missing? Standardized definitions of those implementations refer to the latest gaps that's actually in WG6, right? There was a nice little spreadsheet that was actually just shared as part of WG6. Refer to that. I am not going to repeat all of that. That's there. SMO conversation we just had as part of the panel in terms of what was missing, right? Not to mention some of the other features in terms of power optimizations, workload management, slicing, policy. As we get deeper and deeper into the features, we need more and more. Do we have to wait for all of these things to happen and be standardized? Can we actually move along based on what's available, look at those reference implementations, see the deployment models, and then learn from it and actually build upon that, right? The biggest issue, this was the question that I was coming to you in terms of why those, do we have interoperable implementations? Why is there a vendor lock-in? Do we have an SLA that can be provided? Operators care about SLA. Not every operator is as good as an AT&T or a Verizon. There are many, many, many operators across the globe who don't understand cloud operating models. What do they do in the absence of that? They lean on the vendor. They say, oh, Ericsson, oh, Nokia, oh, somebody else. You run my mobile infrastructure. You manage it for me. So and then the Nokia and Ericsson will say, well, how can I provide an SLA on somebody else's radio or on somebody else's RAN component? So I think we also need to solve this SLA problem if we really have to make this, universally acceptable in terms of and truly push that vision of Open RAN. So this is actually critical. Closed interfaces, people use value drivers as an argument for closed interfaces. Can we actually build better observability? Can we build better models and create the SLA constructs through that better observability? It's something that I believe is core missing. We didn't have as part of the conversation here, but something I think as a community we can pick up and make this happen. Now, there's something about infrastructure management and closed loop. Let me not talk more about that. But telco behavior is really about lowering the risks. How can they lower the risks given the constraints that they have in terms of talent, in terms of CapEx, in terms of money, in terms of capability? And that's really what they do. So that's why they lean on prepackaged solutions everywhere in terms of time to market. And they do succumb to risk, pressure. Can we blame them if they don't have the talent to succumb to risk pressure? The answer is no. So I think they're looking for accountability or single point of resolution, single neck to choke, right? That's what really the telcos are looking for. So if we can provide as part of this community a better way for them to actually de-risk that deployment model, then, and I think yesterday, Ali actually said it as part of the panel, when you talk about performance, you also need to talk about cost. Now, I think you also need to talk about risk. So you need to actually look at not just performance cost, but you also need to look at performance cost and risk in that particular equation and actually manage that overall. So really, and from a reality check perspective, Open RAN implementations are still moving to the right. I had a lot of hope on 23 that we would have some really large implementations. We have seen a few. I think there are more to be coming in 24, but I still see that sliding because of various different challenges that I mentioned and various different conversations that we've had as part of this particular panel, right? There is encouraging signs in terms of growing ecosystems and true interoperability, but let's not make Open RAN a 6G thing. Let's try to get Open RAN going now so that when 6G comes along or when some of those advanced things come along, that we are really truly operating at scale at this. So really my call to action in terms of different recommendations is cloud native implementations are key. The only way you're going to create better abstractions, the only way you're going to delayer things is you need to be able to implement things in a cloud native way, which means stateless, which means microservices, which means, really creating that level of flexibility, that level of scalability that we need. Double down on the work that's being done here, right, as part of these communities, or OSC, OAI, don't do plugfest for the sake of being plugfest. And of course, when we talk about these providers, the large ones, especially AT&Ts, Verizons, T-Mobiles, DTs of the world, use your power, leverage your power to push all the different vendors to create compliant implementations. I love what David said. Hey, it can be done. People have shown it in the street. Why aren't you doing it? Do it more harder to all of the different incumbents and those vendors, right? creating these type of communities and focus on the outcomes. Don't just focus on defining everything to the last T and to the last I and dotting everything. Focus on what's the outcome, leave room for the innovation, drive that particular model. I'm sure we'll all come out really, really, really well. Thank you very much. I appreciate your time, and hopefully this was meaningful.